Now let's look at how to solve the CPM problem using Solver. So we need to first make sure that we have Solver available. Okay, and that is under data, and you should see Solver here. If you don't see Solver here, then you have to switch it on. So you go to File and Options. Okay, then from this list you select add-ins. Okay, then make sure that you have Excel add-in selected and click Go. Now you should see Solver add-in here, and you have to make sure that you check that and then click OK. Then Solver will be visible. Okay, then so we click Solver. Okay, Solver, there are three basic things that we have to set up, and then we have to look at options. The first thing is the objective. Okay. Second is what cell range values need to be changed, and then the third thing is constraints. Okay. And then we have some the options to be, we need to make sure that the options are correctly selected. Now in this CPM problem, what we are trying to do is to find the least possible completion time. Okay, so we want to minimize project duration, and at the same time we want to also minimize the total cost for completing the project at that least possible duration. So there are two things involved, and Solver cannot use two different objective cells at the same time. So you have to do one first and then do the next. So that's what I'm going to show you now. So what we will do is first determine what the least possible project duration time is. So we have to select the project completion cell, which is B20, and here we need to find the minimum possible value for the project duration. And then the changing cells is how many weeks are we going to crash for each of these activities. Okay. Then the constraint at this point for step 1 is the amount of crashing that we're going to do must be no more than the maximum crashing allowed, which is here. So for that you click the add button. Okay, on the left side we have how many weeks are we going to actually crash, okay, which is what Solver is going to find. Then less than or equal to, and there are several possibilities here, but the default is less than or equal to, which is what we want. On the right side of the constraint is maximum crashing allowed, which we've already set up. Okay. All right. So click OK. So for the first step, okay, we are not including cost now. We are only looking at the project completion time. That's it. These are the constraints. Now we have to make sure that unconstrained variables, which is the number of weeks that we're going to crash, that cannot be negative. We cannot have negative crash time. And since some of the formulas in the model involves max function, it is a non-linear model. It's not a linear model. Linear model will be simplex LP, so we need to leave it as GRG non-linear. Okay, and then we have to look at options. But why do we need options? If we solve right at this point, it will give you an answer. Okay, but the question is this the best possible answer? Because when you have a non-linear model, we have what are called local optimum and global optimum. Local optimum is where the minimum in a local area, depending upon the starting values of the changing cells. So these are the changing cells. We started out with 0, 0, 0. So since we start out with zeros, okay, it may find the best possible value around that starting value. It's a local optimum. So if we start with a different set of initial values, okay, and solve, okay, it may give you the same 12, in which case you have a little more confidence that yes, okay, 12 is probably the least possible value, but still you're not sure. You only tried two possible values, right? So a solver gives you a way of automating this process, and that's what is in options. So if you go to options, so here if you go to GRG nonlinear, okay, and if you say if you select multi-start, so multi-start would select random initial values for the changing cells, okay, and then run the model repeatedly and then select the best among the repeats. So here the default is 100, so it's going to repeat the process 100 times and then select the best result out of the 100. Okay, for this problem 100 is okay. It's not going to be a big, if you have a large problem, so trying 100 times may take a long time, and it may be okay. You start the process and then you do something else and come back an hour or two later, and then it's all done. That's good. But since this is only a classroom problem, and you want to get done quickly, so we can probably reset it to, say, I don't know, 25 or something, and then click OK. And you need to make sure that you want required bounds on the variable. So we already have bounds on the variable because these values cannot be greater than or equal to that. So we click OK. All right. So now you solve. So it's going to take a little bit longer than previously. So now you find that the project duration, this least possible project duration, is 12. Okay. It's the same number that we got before. We are still not 100% sure because you only tried 25. We didn't try like 15,000 initial starting off point. Okay, so this is a numerical, or there is a numerical limitation. We're still not sure that this is the best, but we can be quite confident that this is the best. Okay, so now one more thing we can see that here we have non-integer values. Okay, so this may be a problem. If you think that non-integer values are not allowed, okay, then we can go back in and add an additional constraint. Okay, that should be integer. Okay. Now when we add integer constraints, then we have to go back in and do one more thing under options. Okay, so here the default under options is to ignore integer constraints. So you have to make sure that we uncheck that. And then there is one more thing that we have to check, and that is the integer optimality percentage is I think it is set to 1 in Office 365. So that means when solver finds a value that is close to 1% of the least possible value, it will stop. But we want the best possible value, so we change that to 0. Then click OK. Then solve again. Okay. So now it's taking a little bit longer. Okay, so now it has found the answer. And now we do get 12 as the project duration. Now this time all the weeks crash are all integer. Okay. Now that we have found the least possible project duration, now we go to the next step, which is we want to find the least possible project cost with the project duration fixed at 12. So we have to do, we go back to solver. Now this time we change the set objective, okay, from B20 to G23, which is the total project cost, and that needs to be minimized. Okay, so now if you solve, then you're going to get the least possible project cost, which would mean that you don't crash anything at all. Can you go back to your original 22 as the project completion time? But what we want is to make sure that we do crash such that our project duration is the least possible project duration, and for that we want the least cost. So we need to add a constraint that will keep the project duration, okay, so set that equal to 12. Okay, so this constraint will keep the project duration fixed at 12. And then within that constraint, what is the least possible project cost? And once again, the options are like before. We ignore integer constraints, 0 for integer optimality, and we have multi-start. So now solve. Once again, if it takes too long, we can probably go back and reduce the number of population to smaller than 25. But I think 25 is good. Okay, yeah. So now it's found the least possible cost for the least possible project duration. So 12 weeks is the least possible project duration, and we can achieve that at the least possible cost of 14,100.